So, the title of my thing is Untangling Legacy Code. What I'm going to talk about is approval testing. So it's this new technique and something called the Gilded Rose Kata. So before we start, somebody had sent out the thing about our giants are female. So this is Emily Bache. I thought it was appropriate because she's well known for doing katas and TGD and coaching. And the Gilded Rose Kata, the version that I'm using, came off of her website. So if you go to her GitHub, there's a whole bunch of katas there. We'll talk about what those are. She also does this thing called Salmon Coaching. She's got a YouTube channel with a bunch of stuff, and she has a Patreon where she also shares a bunch of stuff. So, anybody ever heard of Emily before? Yeah, it's definitely worth looking up. So what is a kata? So if you've heard the term kata before, you've probably heard it in terms of martial arts. So in martial arts, a kata is practice. It's generally like a series of repetitive movements that you repeat over and over again, usually by yourself. And the idea is it's focused practice. So you're practicing, I don't know, throwing a punch, throwing a kick or something. And you're doing it by yourself because practicing when you're in the middle of a fight, whether it's a real fight or whether it's sparring or something, there's a good likelihood if you screw up, you could get kicked in the head or punched in the face or something, and that's no fun, right? So you practice on your own, and it's this set of movements. And if you have a coach or a trainer going with you, you'll do it 20 times, and they'll be like, okay, this time focus on turning your hips more, or focus on this particular block or this movement. And so it just kind of helps you refine your technique. And in coding, there's a whole group of people who've started creating these coding katas. And what it is an exercise. It's a very well-defined exercise that you do, and you can do it and just focus on tiny little things. And it's basically just building up that muscle memory. So a lot of katas are test-driven development, refactoring, things like that. So test-driven development, you might focus on writing the test first one time, and the next time you might try writing as few tests as you possibly need, or focus on the refactoring step or things like that. And so, you can do the same exercise over and over again, but every time you're kind of tweaking things and doing something slightly different to kind of focus on that. Now, I think there are probably 5 core technical skills that you really need to master to become, a serious software developer. Number 1 is version control. You have to know what version's running, and you have to be able to tie that back to your source code control so you can recreate problems. You have to have some form of testing. I'm a big fan of unit testing. You have to be able to say that whatever you put out actually does what you say it does. You should be doing test-driven development. I don't know that one. I'm maybe a little softer on, but I really like the idea of writing the test first, because that guarantees that you're writing testable code, and the qualities that make your code testable also are just good qualities to have in your code anyway. And then the refactoring step is being able to change direction. I feel like this is one that we don't do enough of in LabVIEW. I feel like a lot of us are afraid of it. And I feel like that forces us to do these big design up front and build in all these features that we don't need. And I think in one of the earlier sessions, I commented something about, don't make stuff reusable. Just make it do what it needs to do. And if it needs to be reused later, then you can refactor it and make it reusable. And then continuous integration, continuous delivery is about making sure that your changes work with everybody else's changes, and we can combine them all, and that everything works and runs and builds. And the continuous delivery part is about getting the code into your customers' hands as quickly as possible, so we can get feedback that we're actually doing the right thing, and that we're actually solving their problem, and that we understood the requirements correctly. And the better you can do these things, the more advanced you are. So this particular kata, the Gilded Rose, is all about refactoring. And there's a book by Martin Fowler. I read the first edition. This is the refactored second edition. He went back and edited it. It's good. I highly recommend it. The short story on refactoring is we want to take our code and we want to draw a black box around it. And it doesn't matter what size the black box is. A black box could be one method. It could be a handful of methods. It could be an API, it could be a class, it could be a library, it could be an actor DQMH module. It doesn't really matter where we draw those boundaries. But within those boundaries, we have an input and an output signal. And we want to make sure that that relationship between the input and the output doesn't change as we're messing about with stuff inside the black box. So we're essentially drawing that black box, and we're changing everything inside the black box as much as we want, and we're still preserving that input-output relationship. And as we do this, we want to take baby steps. We want to take small steps. One of the biggest mistakes I see a lot of developers make is they take too big of steps. So the advantage is taking baby steps. It's less risky. If something goes wrong, it's really easy to get back to where you were, because you're using Git. And, we're going to show you how to use tests so that, as you're taking those baby steps, you take a small step, you verify it. If it doesn't work, you go back. And it's a really interesting iterative process, as you'll see. So if our goal is not to change the behavior, how do we know that we're not changing the behavior? How do we verify that? And the traditional way of doing that is with unit testing. And this is LUnit. And we'll talk about that a little bit more in a few slides. So if you go to Emily Bache's GitHub and you pull down the Gilded Rose, this is the requirements document that comes with it. This is the attempt by the customer to describe their system. So first two paragraphs aren't all that important. It's just kind of background information. So there's a shop called the Gilded Rose that sells magical items. And so we have these items, and they have a sell-in and a quality. And as the days pass, those numbers get changed. And you can see there's a couple special cases there. And at the bottom, there's some more. And so they have a system that does this. And this is them describing the system. The red box is why they're calling us. So the system works as is, but they've got this new supplier, and these new items behave slightly differently, these conjured items. And the yellow box is the constraints. So any good legacy code problem has some constraints. I'm sure you've probably all run into this. We must use this CDAC module, or we must use this DMM, or we must use this enterprise database, or we must stay on Windows 10, or whatever it happens to be. In every good legacy code problem, there's always some sort of constraints. In this case, and we'll look at what this means, but basically, we're not allowed to change the items class or the items property or anything like that. We're allowed to change this update quality method. And we're allowed to add any new code we want. We just can't touch any of the existing code except that update quality. So if you're paying attention, I just described how we're going to add this new conjured thing. And you're saying, well, Sam, you said before that refactoring is about maintaining that input-output relationship, and we're adding a feature, so we're kind of changing that. And it really comes down to this quote by Kent Beck. You may have seen it before. It's a pretty famous quote. But basically, what Kent's saying is, think about, in an ideal world, if you wanted to add this, what would be the easiest way to do it? And maybe your thought is, hey, man, it'd be really easy if I could just add an entry in an non-I file. It'd be really easy if I had a hardware abstraction layer and I could just create a child class. Or if there was a case structure, I could just add a new case. Figure out what that easy change would be, and refactor the existing code to make it look like that, and then make the easy change, and then just add the case structure, add the config file entry. Example in LabVIEW is, you inherit a project, it's got a DMM, the DMM dies, they need a new DMM. The old, and they can't get that model anymore, so they get a different model, right? The old code calls the DMM driver directly. And you're like, well, it would be really easy if I had a hardware abstraction layer in there that, a set of classes so I could just create a child class. It doesn't have it. Well, you can go in and add that to the code and then make the change and then add the child class. So this is the code that you get with the Gilded Rose. Ignore the test me VI at the top for a second. Excuse me. We have an item class. It's got name, quality, and sell-in, and those are all just accessors. And we've got a Gilded Rose class that has an array of items, and it has this update quality method, and we'll talk about those in a minute. But this is their inventory management VI. This is the existing software, the thing that they're describing in that paper that I just showed you a few minutes ago. So on the left, are the controls. They type in the name of the item. They type in the cell and the quality. They say how many days. So they want to calculate 3 days out, 4 days out. And they press a button, and on the right, it spits out the answer. Right? So it's modifying the cell and the quality for each of the items. And this VI actually looks pretty decent. So we've got our array of clusters. We take that, we turn it into an array of items. We hand it off to the Gilded Rose. And for each day that passes, we update the quality. We pull the data back out and reformat it so we can display it. This is pretty reasonable. But the thing that we're going to change is this update quality method. So when we take a look at that, it looks like this. So you can see we're taking the array of items, and for each item, we're checking the name, then we check the quality, then we update the quality, then we check the name again, then we check the cell, and then we check the quality, we update the quality, and it keeps going. There's actually 3 pages of this. So here we're checking the name again, here we're checking the cell in, then we're checking the name multiple times again, along with the quality, and we're updating the quality. And you can see I put the little navigation window at the top so you can get an idea of how big this thing is. So if you've been doing LabVIEW long enough, you've probably inherited something that looks somewhat like this. This is kind of a common pattern where you get these really nested, deep case structures. I remember when I first started, I inherited a project that had not case structures, but stacked sequence structures, and they were 17 deep. So this is definitely a common thing. And so we're going to work on trying to clean up this VI. And if we open up the VI metrics, you can see the inventory management, which was pretty reasonable. That has 15 nodes, and the Gilded Rose has 112. And all these other ones are just accessors. Everybody can hear me, right? The chat's kind of quiet. I just want to make sure people are following along. Perfect. Ha. All right, good. Thank you, Alan. Always count on your sense of humor. All right. So this is the test me VI that I pointed out at the beginning. This I added, and it's just a really simple way to run a test because it just takes one item for one day and spits out the answer. That's a very interesting thing to know, Jesper. I can't imagine trying to nest 255, but that's a lot of wiring. I guess you could script that just to test it out and see how many. All right, so where to start? Now, some of you might just be tempted to just start ripping stuff out and changing all the things that you don't like. But it should be obvious from looking at that code that that's kind of precarious, right? That there's a whole lot of logic going on there, and it's not entirely clear what's going on. So just ripping things out, probably not the best idea. Some of you might be saying, well, Sam, I know the answer. We'll just take all that ugly code and throw a case structure around it, and we'll say, hey, let's just look at the name, and if it's conjured, we'll do whatever the conjured items are supposed to do. And if you go back and read the description, it says conjured items decay twice as fast as normal items, and that's all it tells you. So, okay, but do you know how normal items are treated from the other VI, right? From the other code? You can't really tell that. You can look at that and you can kind of try to figure it out, but that's kind of fraught. And I will say, you could go back to the requirements document, but again, the requirements document, there's some holes in there and edge cases that aren't really covered. And if we want to keep the behavior exactly the same, that's not really going to work. And I kind of view this approach as like taking your plate when you're done with dinner, you walk over and there's a bunch of dirty dishes in the sink and you just throw another dirty dish on the sink. And yeah, you solved your problem, but whoever comes next is going to have to do all those dishes anyway, and they're going to need to be done. So you might as well just do the dishes. And this is a refactoring kata, so that's what we want to practice. So again, we're trying to change what's in the black box without changing the input-output relationship. To do that, we kind of want a safety net. We want to be able to make changes and feel pretty confident that we haven't changed anything. Now, we can do that with traditional unit tests. So those of you who've done unit testing before, this may look familiar. This is LUnit, but it's very similar to VI tester. Test me is the sub VI that I'm testing. I'm passing in normal item and two numbers, 5 and 10, and I probably should have labeled those. And then I've got, that's the bottom cluster. And the top cluster is, this is the result I expect. I expect that should spit out normal item and the numbers 4 and 9. And if it does, then hey, test passes, and that's great. And if I change something that breaks that relationship, the test will tell me. Now, there's a problem with using unit tests like this and doing the traditional unit testing thing is there's a lot of test cases. If you look in that document, you'll see there's 4 types of items plus the conjure item, so that's 5. The quality, while it can be less than 0, it can be between 0 and 50, it can be greater than 50. Our sell-in date is either expired or not. And so if we do 5 times 3 times 2, that's 30 cases. For each of those cases, we have to figure out what input values exercise that case. And then we got to manually calculate what the output values are. And that doesn't include special cases like the backstage pass for the concert, which its value depends on how far out you are. And it's more than just has the date expired or not. As it gets closer, it goes up in value. Okay. So you have to do all of this. And the only thing you really have to go on is the requirements document that they gave you, which is not complete. And you don't necessarily know that, right? Going into it, they'll tell you it's complete. But if you look closely, you'll find there's some edge cases. So there's this idea that we can use called approval testing. It's not something I made up. Yeah, they're never complete, Alan. That's exactly it. So there's this idea called approval testing. You can go look it up. I think approvaltest.org is the website. A guy named Llewellyn Falco invented it. I just kind of created a port in LabVIEW. So it's on VIPM. You can download it and install it. I just released a new version. You want version 2.0 or 2.1 or whatever the current version is. Version 1.0 is like proof of concept. 2.0 is much better. And you also, for this particular exercise, we're going to use LUnit. So you can also get that on VIPM. If you've never used it, it's very similar to VI Tester, just much faster and a little bit nicer. So to create my test, I'm going to click on the little check mark with the plus sign. That's going to create the new test case class for me, very similar to VI Tester. And then I create a new dynamic dispatch VI inside there. I name it something starting with test, and LUnit will pick it up as a test VI. And then what I'm going to do is I'm going to go into the palettes and I'm going to find the approval testing palette. And there's that LUnit extension, which is what I'm looking at here. And they're just some VIs that you can drop in. And when you drop it in, it actually, it's like a merge VI. So it puts all this stuff on your block diagram. And so then I switch to the front panel, wire everything up. I come back here and I read the notes. And you can see that at the top, we have the VI that we're going to test. We have a reference to a VI, and we have a map. And the map maps an input, so one of the connector pane inputs, to a series of values. Right, so in this case, input 1 is a Boolean, and it's going to get mapped to true or false. Input 2 is going to get mapped through all those double values. And what the assertion VI there, the thing marked combos, what that's going to do is it's going to use VI server to run that VI with each possible combination of inputs. And it's going to record in a text file which set of inputs led to which set of outputs. And then every time you run the test, it's just going to do that same thing, and it's going to compare it to the previous time. And so if that input-output relationship changes due to something that we've changed as we're refactoring and we've broken that relationship, it will let us know. And so I do all that. And in our case, it looks kind of like this. I've got my test me VI. Yes, actually, yes, you should definitely say hi to Anton. Yes. Thank you, Jesper, for reminding me. So we have the map has 3 controls: name in, sell in, and quality in. And the name in is going to go through age, breed, backstage passes, so first hand of Ragnaros or whatever that is, and none of the above. And then the sell in is going to go through a couple values in the quality. And I got those values by looking at all the case structures and seeing what was driving each of the case structures and trying to pick numbers that I thought would hit every single one of those case structures. So what I want is when I run my test, I want every single line of code in there to get executed at least once. And so I run the test and it generates 288 test cases. So if you're going to do that by hand, that's a lot of test cases to write by hand. You could go through and double check all of these and check them against their requirements document. That would be one thing. For this, I'm just assuming that it works for them. And if there's a bug, they're okay with it. And if they're not, hey, I can point that out to them later and we can fix it later. But for now, I just want to keep it exactly the same as it is. And so I'm just going to highlight all this and I'm going to move it over to the approved file and click save. So this window is actually a tool called Beyond Compare. So when you install approval tests, you can, if you also have Beyond Compare installed, it will pop up this nice little text diff viewer. There's also a free alternative called WinMerge. The documentation for the approval test has all the information on how to do that. But basically, you just install an approval test, finds it, and it runs, and it's fine. So now I've got some tests. And what I'm going to do is I'm going to run the test again just to make sure that it passes, which it should. And before we do that, though, I'm going to go into LUnit, open up the UI, and I'm going to click the coverage analyzer. And I want to see the test coverage. Yeah, so Jesper points out, Alan says he likes Beyond Compare. Jesper says he likes VS Code. So you could use VS Code. You could use Git diff. There's some other tools. Approval test doesn't support that out of the box, but you could probably add that. Or if anybody has a favorite one that's not supported, come talk to me and we can talk about how to add that. But if you select Coverage Analyzer, it'll pop up this code coverage tool. And if you look, the Gilded Rose update quality now has 100% code coverage. So what that means is when I run that test, every single line of code, every single path in there is getting executed at least once. So that gives me a lot of confidence that I've covered the whole entire thing with tests as best I can. It doesn't necessarily mean that like there's multiple case structures in there. It doesn't mean every combination of case structures, like it goes through this case on this one and that case on another one. And it doesn't hit all the potential paths, but it hits each path at least once. And the ones that say 80%, those are just because they are accessor VIs and nowhere in my test am I actually passing an error in. So it's not really executing that error case, but I'm okay with that. That's fine. What I really care about is the 100% on the update quality method. Anybody use code coverage at all? Cool. Yeah, it's one of those metrics. It's like, it's a good indicator. If you're going to use code coverage, my recommendation would be to look into something called mutation testing, which is also an interesting thing. And basically what mutation testing does is it goes into your code and it randomly changes things and runs the test and it tells you which tests failed. So if something in your code changes and no test failed, that's bad because that means you weren't testing that line of code. So it gives you a little more information than just the test code coverage number, which is valuable in a way, right? Because if it's super low, you're like, okay, yeah, we don't have many tests. If it's high, it's good, but it doesn't necessarily mean that you're like making assertions that are actually valuable. Anyway, that's aside. So now we've got some tests, right? So let's take a hacksaw to this code and start chopping it up and moving things around and rearranging them and start doing some refactoring. So when I first looked at this, so sometimes when you're doing refactoring, you have a really good idea of like, you do the Kent Beck thing. You're like, okay, what should this look like? And you're kind of moving towards that. In this case, I didn't really have a good sense of what was the easiest way to add this. But I was like, I'm just going to go in and start making some small changes and rearranging things and see what kind of emerges. So oftentimes, if you just start making small changes, then suddenly you'll start to see some patterns and pick out some stuff. And you'll be like, that looks like this design pattern or that design pattern. You can just kind of like pull them out. So in this case, in both of these cases, the inner two case structures and the false case do nothing. So it doesn't really matter what order I check the quality or the sell-in date on either of those. So I just swapped them. And I ran my test. Cool. Pass. So now it looks like the top one. And I just thought, well, I'm comparing the quality against 50 and I'm doing that twice. Why don't I just do that once and combine those two case structures? And immediately I got smacked and my test said, no, you can't do that. It broke. Anybody want to guess why? Can anybody see why? All right. Well, in the interest of time, the reason it doesn't work is because if you look carefully at the top part, when we compare quality the first time versus the second time, you'll see that in between the quality could potentially change, right? So you're not really comparing the same numbers each time, right? The comparison is different potentially. And that's kind of what happened. So I looked at this and I said, and you can look at the lines. The lines on the left are what it got, and the lines on the right are what it's expecting. And you can see that the quality went up to 51 and it should have stayed at 50 on the right-hand side. And if you go back and read the requirements, it says, hey, the quality can never go above 50. So, right. So what's happening is it's checking, it's adding one. And then if it can still add another one, then it adds another one, depending on the sell-in date. So at this point, I have two choices, and either one's valid. I could just undo that change and go take a step back and say, okay, let's find something else to change. In this case, I thought the answer is pretty simple because I'm like, well, all I really have to do is just coerce that quality value out to be 50 or less, right? So if it goes over 50, I just replace it with 50. And so I did that, and I rearranged things a little bit. But basically what I figured out is if quality is less than 50, then depending on the sell-in date, we add a certain amount. And if it's over 50, we just peg it at 50. And that worked. And hey, all right, great. We're down to 103 lines now. So I got rid of like 10% of my code. Great. Then I went back here at the beginning and I saw that, hey, we're checking the name, and then we're checking the quality, we're checking the name again. I would like to just check the name once. I would also kind of like to drive the case structure directly off of the name, if that's possible. And so I tried just moving that first-hand Ragnos thing out, and that broke and it didn't work, and I threw it away. I came back and I said, okay, well, the first thing I can do is just get rid of the logic there. And right, so that case structure has a true and a false case. Well, one of the cases is it's equal to age, brie, or backstage passes, and the other cases it's not. So I just removed all that logic, and I just had two cases now, right? And that works. And now we're down to 96. We're down to double digits. That's good. And then I started looking, and I realized in these false cases here, nothing happens in those inner false cases. And I realized that the sulfurous case is actually doing nothing. So what I can do is I can add a case for sulfurous to the outer, that main case structure that does nothing. And once I do that, if the name is sulfurous, that case will pick it up. So this check in here in the default case, I don't need to do that because I already know the result of it. So I can get rid of that checking code. And I do that, and I get down to 90. Cool. And now I have this sulfurous case that does nothing, and I look at the next case structure, and it's checking if it's not equal to sulfurous, it's doing something. And the false case is doing nothing, right? So if it is sulfurous, it's still doing nothing. So I figured, well, what I can do is I can add this code that modifies the cell, and I can add that to the other case structures, right? Since I'm already checking the name, I don't have to check it again. And so I do that. But now I'm down to 88. But I got rid of one of those case structures. So that's good. And now I'm looking inside the aged, brie, and backstage passes case, I'm checking the name again. Well, if I separated these two cases, if I had two copies of the same case, one for aged, brie, and one for backstage passes, I wouldn't have to do that check because depending on which one I'm in, I would already know the result. So that's what I did. I duplicated the case, and then I said, okay, in that case, I know what the result is here, so I can remove that check and just drop in the correct code from inside that case. So I end up like this. So now I've got two cases. I got one for backstage passes and one for aged brie. And I'm not doing that check again. That's cool. And I also did some little things here too, cleaning up. Like I replaced like the -1 with a decrement, and I replaced the +1 with an increment, but like very minor little things. And I run it, and it passes, and we're down at 83 now. That's good. Now I start looking at the last case structure on the far right, and I noticed that we're checking the name a lot. I want to move those all close together so I can kind of collapse that into one case structure. Why not use the numeric case selector 0 to 50? That's a good question, Jesper. And that is totally a valid approach as well. I chose not to do that. So, but we can talk about more about that at the end. So for now, though, I have what I'm going to do is swap these two because, again, I looked, and in the false case of the two innermost case structures, it's not doing anything. So it doesn't really matter what order we check. So check the name and the quality because unless they're both true, we're not going to do the update the quality. So I swapped those. Great. Now it kind of looks like this. And now I'm at a point where I can kind of collapse all those case structures that are checking the name into one case structure that checks the name. But the first thing I did was I just removed those checks and I just had a default and then whatever the thing it was checking for case. And then I collapsed them down and I ended up with something that looks like this one at the bottom. And now I'm down to 68 nodes. And my test passed and everybody's happy. So now I looked at this and I said, okay, well, I'm checking the name in the first case structure. The second case structure, I'm checking the cell in, but then inside there, I'm also checking the name, right? In the false case, if the cell-in thing check is false, it's not doing anything. So I can take this and I can take the age brie case and I can add a thing in here to check the cell-in, and I can move the code in the age brie case in the second case structure into the first case structure. So it looks kind of like this, right? This is the age brie case. I added a check for the cell-in, and then I moved the code from that age brie case from that second case structure into the first one on the left. And I did that, ran the test. Okay, great. And then I did it for all of them and eventually deleted that case structure. And surprisingly, the number of nodes actually went up. Why? I'm not entirely sure, but I like duplicated some code or something. But that's fine, actually. Because sometimes, when you're doing refactoring, sometimes it looks a little worse before it looks better. But we're definitely moving in the right direction because now I can fit it all on one screen. So that's definitely worth a few extra nodes there. So now it's on one screen. I've got one case structure or one case for each of the different types of items. So this is pretty good. You could just stop here. I'm going to go clean it up a little bit more. And this is not like the best code ever. Okay. This is just kind of like cleaning it up, adding some comments, making it a little bit more readable. You could nitpick and find things wrong with this, and that's fine. Usually when you do a kata, you set a time limit. So I hit my time limit and I was pretty happy with what I got. And I was like, I'm not going to keep going because, refactoring, you can go way down that rabbit hole and keep polishing things. And there are definitely things to polish here, but I think we're pretty good. And just looking at the metrics, so I added some more metrics to this. Yes, Alan, that is true. And I will talk about that in a minute. Originally we had 112 nodes. Now we have 54. That's like well over half. We started with 17 structures. We're down to 6. We started with 34 diagrams. We're down to 16. We started with a nesting level of 6, and we're down to 4. So not half there, but better. And we went from 168 wire sources or terminals to 84. So we basically cut our code in half. And it still does exactly the same thing. And we know that because we have the tests to prove it. So the question is, have we made the change easy? And I know some of you, probably even Alan, are going to say, hey, you could have made it even easier, but it's definitely easier than it was. Because now, if we look at this, conjured items degrade in quality twice as fast as normal items. Well, if we look at the code, we'll skip ahead one slide. If we look at the code, the default case, right, you can see that the only place, if you look at this, the false case does nothing. So in this case, the default is the normal item for the top case. In the true case here, this is where we're decrementing, right? We're either decrementing by 2 or 1, depending on the sell-in date. Well, we could very easily just copy that case and change it to 4 and 2. And before I did that, I wrote a test. And I could have ran this and it wouldn't have handled the conjured items correctly. And I could have went through the list and said, okay, well, in this case, it should do this. In this case, it should do that. Instead, I just verified them after the fact. So I made my change, ran the test. It popped up the beyond compare, and I looked at it, and I carefully looked at each line and said, yes, this is doing the right thing in each case. Great. I proved it. And then I ran it and it passed. So taking this exercise further, there's a lot of different solutions. You could do a lot of different things. As Jesper mentioned, you could use the number to drive the case structure. You could have 0 to 50. That's also a totally valid thing to do. You could also take where I ended and you could create some sub-VIs and clean things up even more. Some of you, like Alan, are probably wondering, why didn't I use OOP? Why didn't I just create a new item class? And part of it was the way I interpreted the thing at the beginning. And it said specifically, don't touch the items class. I think if you relax that and just said, don't change anything in the items class, but add new methods, then you could easily add a new method, a dynamic dispatch method, and you could do classes. So you could totally do that. Without that, it would be kind of hard to do an OOP solution. You probably could figure out a way to do it. You could do something with like strategies or something, but it would be kind of cumbersome. But the beauty of this is you can impose your own constraints. You can change the constraints. You can say, I'm only, you could add something that says, hey, each sub-VI is only allowed to have 5 nodes if you create new sub-VIs, or you could do, any kind of number of things that you wanted. So adding the constraints just like forces you to be a little more creative and try out different things that you might not normally try out. And it helps you to kind of figure out what works and what doesn't, and where the sticking points are and what some of the problems are. So I had all these lessons learned. Really, the basic thing, there's a lot of little things that you could take out of there. The big thing is get your code under test so that you can change it and be confident that you're not going to break things. And then just make small iterative changes and just keep going until you get to a point where you're like, hey, this looks pretty good. I've made the change easy that I want to make, and then go make the easy change. There is a caveat with the approval testing, and that is it cements in the existing behavior. And sometimes that cements in existing bugs or undefined behavior. So basically, if you look at the description of the problem, it says quality can never be negative. Okay, so I'm checking to see if it's greater than 0. But if it's less than 0, should I coerce it to 0 or not? In this case, what the code is doing is not coercing it to 0. The code is just saying, if it comes in and it's negative, we just pass out the same negative value. Is that a feature or a bug? Nobody knows. Right? So from my point of view, if I'm working with a customer, I would rather be able to say, rather than taking a guess and then being wrong, because like somebody's like, hey, I was relying on that, I would rather just say, I did exactly what the original one did, and here I can prove to you that's what the original one did. And if you want to change it, let's change it. Thank you for the clarification, Jesper. You can go try this kata on your own. If you want the original kata, it's at Emily Rose's GitHub, but it doesn't have a LabVIEW version. So I took the Python version, which I don't know which one's actually the original, but I took the Python version because that's what I understand. And I took it and I rewrote it as best I could in LabVIEW. It's actually really hard to write bad code in LabVIEW once you used to writing nice code. Because I showed this to somebody and they're like, oh, that doesn't look that bad. At least you only have to scroll in one direction. So I guess I could have made it even more messier if I wanted. So the middle link is the one to the bare kata, just like as is. And then my solution, the one that I just presented, is under the GLA 24 Gilded Rose. So basically every time I made a change, I made a commit. And so you can kind of go through it and see the whole thought process and see how it all works. And then there is a presentation on this kata from Sandy Metz. It's in Ruby. It's called The Small Things. I think it's pretty good. It shows an object-oriented solution in Ruby, which is kind of cool. And then lastly, so this type of exercises, these katas, there's this thing called Saman coaching. It's kind of new. Emily Bache has been promoting it. She's teaching classes on how to do it. I've been taking some of her classes. And basically, it's a 2-part process. So if you hire a Saman coach, what they do is the first hour or so, you do a learning hour, which is like a small targeted exercise. So you might do a refactoring exercise like this, maybe a little more targeted. And then you take whatever you learned from the learning hour, and then you go together as your team, as an ensemble, and you pull out your code base and you try to apply the lesson and all the previous lessons. Thank you for the link, Jesper. And then you have a coach sitting there and watching you and kind of guiding you. And also then as the coach, in the back of your head, they're sitting there and you're like, okay, well, they could use a lesson on this technique or that technique. It would be really helpful. So it's kind of practice and application, because often, and I hopefully I'm not the only one who this happens to, but I sit and I watch a presentation on some practice, whether it's actor framework, TDD, whatever it is, and the person giving the presentation makes it look really easy. And then you go to try to practice it. on your actual code base and you find out that like, hey, refactoring is not as easy as Sam makes it look in the presentation, because I'm talking to a piece of hardware, and how do I figure that out, and how do I change that? And so having somebody there to help you through that is useful. So if anybody's interested in that, I'm happy to talk more about that later. I'll put it back on the links in case anybody didn't get those. Jesper threw one in the chat. So we are 4 minutes early. So questions, comments, concerns. Does anybody think that exercise is useful to go do? Or are they like, yeah, that's kind of boring, Sam. That doesn't bear any resemblance to what I do every day. Yeah, and there's a whole bunch. If you go to Emily Bache's website, there's a whole bunch of katas. The really easy ones to get started with are the TDD ones, because they give you a problem description with no code. So those like translate to LabVIEW really easily because they're like language agnostic. The problem with the refactoring ones is you need a starting point. So my plan is to slowly go through some of the refactoring katas and kind of create some starting points in LabVIEW so that people have some things that they can play around with. And again, the great thing about the kata is you can take that kata and you can do it over and over and over again, and you can play around with it and try different things. And there's no danger of like, if you screw it up and it doesn't work, your test doesn't quite cover everything, you get to the end and something's broken, doesn't matter. So yeah, definitely. Advent of Code Part 1 versus Part 2. Yeah, I found for Advent of Code, I found that writing the test first, actually, I found it really helpful. I feel like that's a great way to practice test-driven development because they give you test cases right up front. So it's very easy to write a test to begin with. Although the test cases don't necessarily hit all the edge conditions, I've noticed in Advent of Code. So sometimes the test pass and you run and you get part 1 and then you get to part 2 and your test pass and then it doesn't work. One of the key things to mention though too is that the thing that makes this exercise possible, I think, is the approval testing, which is a really powerful approach to being able to generate a lot of test cases at once. So that's definitely worth checking out. And it supports VI Tester, it supports LUnit, it supports Karaya right out of the box. It's just got a palette. You just drop them in your VI and you're ready to go. So cool. Thank you all for coming to my talk. Hopefully you found it very useful. Yes, so the tool that does the combinations is called approval testing. You can look it up in VIPM. And when you get it, you get a palette, and you just go into the palettes, and there's an LUnit palette, and then there's a palette inside there for each of the different testing frameworks, and you just go to that and start dropping those on your block diagram of your test VI, and it's got some directions there that should help you. And if you have Beyond Compare already installed, then it'll find it and run it, and everything just kind of works out of the box. At least that's the deal. That's what it's supposed to do. If it doesn't, let me know. Yeah, cool. All right, well, we are at time, so I will thank you all for coming to the GLA Summit.